Hello everyone, welcome to Neet 2018 Physics Solutions. The volume V of a monoatomic gas varies with its temperature T as shown in figure. The ratio of work done by the gas to the heat absorbed by it when it undergoes a change from state A to state B is. As we can see from the graph, it is a volume temperature graph. It is a straight line passing through origin, so it represents a constant pressure process. Applying first law of thermodynamics, dq equal to du plus dw, du by dq, that is the amount of heat energy given to the gas that goes into internal energy, can be given by 1 by gamma. Then fractional heat taken for work done by the gas dw by dq is 1 minus du by dq, that is 1 minus 1 by gamma. Since the gas is monoatomic, the value of gamma is 5 by 3. Upon simplification, we get the fractional amount of heat taken as work done as 2 by 5. The fundamental frequency in an open organ pipe is equal to the third harmonic of a closed organ pipe. If the length of the closed pipe is 20 cm, the length of the open organ pipe is. Given fundamental frequency of open organ pipe is third harmonic of closed organ pipe. Length of the closed pipe, let us say LC, equal to 20 cm. Length of the open pipe is L0. So apply the given condition. V by 2 L0 equal to 3 times V by 4 LC. From there we get L0 equal to 13.2 cm. The efficiency of an ideal heat engine working between the freezing point and boiling point of water is. Freezing point of water is 0 degrees centigrade, that is 273 Kelvin. Boiling point of water is 100 degrees centigrade, that is 373 Kelvin. Efficiency of an ideal heat engine is given by work done by input heat, that is 1 minus Q2 by Q1, which also can be written in terms of absolute temperatures. So efficiency equal to 1 minus temperature of sink by temperature of source. That comes out to be 26.8%. At what temperature will the RMS speed of oxygen molecules become just sufficient for escaping from the Earth's atmosphere? Escape velocity from Earth's atmosphere is 11.2 km per second. RMS speed of a gas molecule is given by the formula root of 3RT by m, which can be rearranged into root of 3 times Kb into T by m, where Kb is Boltzmann's constant, m is mass of each molecule, and T is absolute temperature. Upon substituting the values, we get Vrms equal to 11.2 km per second. So the temperature is 8.360 into 10 power 4 Kelvin. Unpolarized light is incident from air on a plane surface of a material of refractive index mu. At a particular angle of incidence I, it is found that the refracted and reflected rays are perpendicular to each other. Which of the following options is correct for this situation? Angle of incidence I equal to sin inverse 1 by mu. Reflected light is polarized with its electric field vector perpendicular to the plane of incidence. Reflected light is polarized with its electric field vector parallel to the plane of incidence. Then angle of incidence I equal to tan inverse 1 by mu. When the reflected ray and refracted ray are perpendicular to each other, the angle of incidence is known as polarizing angle. Polarizing angle I equal to tan inverse mu. Incident light is unpolarized. Reflected light is polarized with dot components in it, and refracted light is polarized with dot and arrow components in it. So the reflected ray contains dot components, which are the components perpendicular to the plane of incidence. In Young's double slit experiment, the separation d between the slits is 2 mm. The wavelength lambda of the light used is 5896 Armstrong unit, and the distance d between the screen and the slits is 100 cm. It is found that the angular width of the fringes is 0.2 degree. To increase the fringe angular width to 0.21 degree with the same lambda and d, the separation between the slits need to be changed to. Let us see the given data once again. Separation between the slits small d 2 mm, Wavelength of the light used, lambda equal to 5896 Armstrong unit. Distance between the slits on the screen, capital D equal to 100 centimeter. Angular width of the fringes theta equal to lambda by d. From there we can have theta is proportional to 1 by d, that is small d. So taking the ratio theta 1 by theta 2 equal to d2 by d1, from there we get d2 equal to 1.9 millimeter. An astronomical refracting telescope will have large angular magnification and high angular resolution when it has an objective lens of angular magnification of astronomical telescope m equal to f0 by fe, where f0 is focal length of objective lens and fe is focal length of eye lens. We can see magnification is directly proportional to f0. Angular resolution of astronomical refracting telescope r equal to lambda by a, where a is diameter of the objective lens. Resolving power of astronomical telescope is given by 1.22 lambda by a, where again a is diameter of the objective lens. So from here we can see that the resolving power is inversely proportional to diameter of the lens. So in order to satisfy the given condition, the astronomical telescope's objective lens should have larger focal length and smaller diameter. The kinetic energies of a planet in an elliptical orbit about Sun at positions A, B and C are Ka, Kb and Kc respectively. AC is the major axis, SB is the perpendicular to AC at the position of Sun S as shown in figure. Then, this bit involves little bit of mathematics. See the diagram carefully, it is an ellipse. From the diagram we can see RC equal to A of 1 plus E, RA equal to A of 1 minus E, and RB equal to B square by A, that is equal to A times 1 minus E square. Here A is a semi-major axis, B is a semi-minor axis, E is eccentricity. Relation among RA, RB and RC we can see from the formulas. RC is greater than RB and that is greater than RA. Applying conservation of angular momentum, L equal to mvr, it is constant. So as mass is already a constant value, we can write Vr equal to constant, from which we get V is inversely proportional to R. Relation among Va, Vb and Vc, we can see Va is greater than Vb and greater than Vc. So the relation among kinetic energies also, Ka is greater than Kb and that is greater than Kc. A solid sphere is in rolling motion. In rolling motion, a body possesses translational kinetic energy as well as rotational kinetic energy simultaneously. The ratio of translational kinetic energy to sum of translation and rotational kinetic energies of the sphere is, translational kinetic energy is half mv square, rotational kinetic energy is half I omega square, which can be written as half into mk square into omega square, where mk square is the moment of inertia of the object in terms of k, that is radius of gyration. Writing omega as v by r and simplifying it, we get rotational kinetic energy equal to translational kinetic energy multiplied by k by r whole square, where k is radius of gyration and r is radius of the sphere. Now the total kinetic energy, which is a sum of translational and rotational kinetic energies, comes out to be kt times 1 plus k square by r square. For a solid sphere, k square by r square is 2 by 5. So the ratio is 5 by 7. If the mass of Sun were 10 times smaller and the universal gravitational constant were 10 times larger in magnitude, which of the following is not correct? Time period of simple pendulum on Earth would decrease, walking on the ground would become more difficult, raindrops will fall faster, G on Earth will not change. Time period of a simple pendulum t equal to 2 pi root L by G. Writing the formula in terms of capital G, we get 2 pi root Lr square by Gm as small g equal to Gm by r square. From there we can see time period of a simple pendulum is directly proportional to 1 by square root of G. So statement 1 is correct. Gravitational force on the surface of the earth F equal to G times capital M small m by r square. So we can see gravitational force is directly proportional to capital G. Statement 2 is correct. Acceleration due to gravity on the earth, small g equal to gm by r square. So small g is directly proportional to capital G. So the third statement is correct. Acceleration due to gravity on the earth is gm by r square. As we can see, small g is proportional to capital G. So the fourth statement is wrong, as it is given that g on the earth will not change. A solid sphere is rotating freely about its symmetrical axis in free space. The radius of the sphere is increased by keeping its mass the same. Which of the following physical quantities would remain constant for the sphere? Given that the radius of the sphere is increased by keeping its mass constant. Now let us see the physical quantities one by one. Moment of inertia I equal to 2/5 of mr square. So it increases. Angular velocity omega equal to L by I. Omega is proportional to 1 by I, so it decreases. Rotational kinetic energy half I omega square, that can also be written as L by 2I. So rotational kinetic energy is proportional to 1 by I, so it decreases. Coming to angular momentum, it remains constant as there is no external torque acting on the system. A metallic rod of mass per unit length 0.5 kg per meter is lying horizontally on a smooth inclined plane which makes an angle 30 degrees with the horizontal. The rod is not allowed to slide down by flowing a current through it when a magnetic field of induction 0.25 Tesla is acting on it in vertical direction. The current flowing through the rod to keep it stationary is. Mass per unit length of the rod is lambda equal to 0.5 kg per meter. The magnetic force acting on the rod is BIL. So B is 0.25. Let us say I is current, L is length of the rod. For equilibrium, Fm cos theta should be equal to mg sin theta from the diagram. So BIL cos 30 equal to lambda Lg sin 30. Upon simplification, we get current flowing through the rod equal to 11.32 ampere. An inductor 20 millihenry, a capacitor 100 microfarad and a resistor 50 ohm are connected in series across a source of EMF V equal to 10 sin 314t. The power loss in the circuit is. Frequency of the supply is 50 Hz. Inductive reactance XL equal to omega L, that comes out to be 6.28 ohm. Capacitor reactance XC equal to 1 by omega C, which comes out to be 31.85 ohm. Now the impedance of the network equal to root of R square plus XL minus XC whole square, which comes out to be 56.2 ohm. Now the RMS current flowing in the network IRMS equal to VRMS by Z, that is 10 by root 2 is the RMS voltage divided with 56.2, which comes out to be 0.13 ampere. Now the power loss taking place in the circuit P equal to VRMS into IRMS into cos phi. Upon simplification, it comes out to be 0.79 watt. A thin diamagnetic rod is placed vertically between the poles of an electromagnet. When the current in the electromagnet is switched on, then the diamagnetic rod is pushed up out of the horizontal magnetic field. Hence, the rod gains gravitational potential energy. The work required to do this comes from. Diamagnetic materials are repelled by magnetic fields, that is, they travel from stronger magnetic field to weaker magnetic field. When the current is switched on in the electromagnet, the magnetic field created between the poles will make the diamagnetic bar to move up, that is high field to low field. So the work required to lift the diamagnetic rod comes from the current source. Current sensitivity of a moving coil galvanometer is 5 division per milliampere and its voltage sensitivity is 20 division per volt. The resistance of the galvanometer is. Given current sensitivity of the MCG is 5 division per milliampere and voltage sensitivity of MCG is 20 division per volt. Current sensitivity can be given by theta by I, which is VAN by C. Voltage sensitivity is given by theta by V, which is theta by I into R, that is 1 by R times theta by I. Now substituting these values in voltage sensitivity, we get R equal to 250 ohm. In the circuit shown in figure, the input voltage Vi is 20 volt, VBE is 0 and VCE is 0. The values of IB, IC and beta are given by. See the diagram, it is an NPN transistor connected in CE configuration, that is common emitter configuration. So in this configuration, input is given to base and output is taken from collector. So the base current IB equal to Vi by RB, which comes out to be 40 microampere. Collector current IC equal to VC by RC, which comes out to be 5 milliampere. So the current gain beta, output current by input current, that is collector current by base current, that is coming out to be 125. In a PN junction diode, change in temperature due to heating does not affect the resistance of the PN junction, affects only forward resistance, affects only reverse resistance, affects the overall volt ampere characteristics of the PN junction diode. Takes some time to go through the volt ampere characteristics of PN junction diode graph. You see it clearly. The current flowing through the diode is given by I equal to I naught of e power V by eta Vt minus 1. Let us try to understand the terms in the formula. I naught is reverse saturation current which is flowing due to minority charge carriers. V is applied voltage. Eta equal to 1 for germanium and 2 for silicon. Vt is volt equivalent of temperature given by the formula capital T by 11,600, where capital T is absolute temperature. From the diagram and the formula we can see as the temperature changes, the overall Vi characteristics of the PN junction change. In the combination of the following gates, the output Y can be written in terms of inputs A and B as. See the logic circuit, it is a combination of 2 AND gates, 1 OR gate and 2 NOT gates. We can see the output of first AND gate is A dot B bar, the output of second AND gate is A bar dot B, which are fed to the OR gate. The output comes out to be AB bar plus A bar B, which is an exclusive OR gate. A carbon resistor of 47 plus or minus 4.7 kilo ohms is to be marked with rings of different colors for its identification. The color code sequence will be. As we can see from the options, there are 4 color bands given, so it is a 4-band color coding system. In this, the first 2 bands represent the significant figures, the third band represents power of 10 and the fourth band represents tolerance. The resistance of the carbon resistor 47 plus or minus 4.7 kilo ohms. Let us calculate the percentage tolerance from here. It is 47 into 10 power 3, that is 1 kilo is 10 power 3 plus or minus 4.7 into 10 power 3, which comes out to be 47 kilo ohms plus or minus 10%. So the color coding chart is given here. You go through it and try to by heart the color coding chart, from which you can write the color combination to be yellow, violet, orange and silver. A set of n equal resistors of value R each are connected in series to a battery of EMF E and internal resistance R. The current drawn is I. Now the n resistors are connected in parallel to the same battery, then the current drawn from the battery is 10I. The value of n is. Effective resistance in the first case, that is when they are connected in series, is NR. So the current drawn from the battery I equal to E by external resistance plus internal resistance, which comes out to be E by R times 1 plus N. Now the effective resistance in the second case, when the resistors are connected in parallel, is R by N. The current drawn from the battery 10I equal to E by R by N plus R. Solving the two equations, we obtain N equal to 10. A battery consists of variable number n of identical cells having internal resistance small r each. which are connected in series. The terminal of battery are short circuited and the current I is measured. Which of the following graphs shows the correct relationship between current and number of cells in the battery? Internal resistance of each cell is small r, so the total internal resistance of the series combination is Nr. Let the EMF of each cell be E, then the total EMF is Ne. Current flowing through the circuit I equal to total EMF by total resistance. That comes out to be E by R, which is a constant value. So the third graph is the correct representation. A body initially at rest and sliding along the frictionless track from a height h as shown in figure just completes a vertical circle of diameter d. The height of the inclined plane h is equal to speed of the body at the bottom of the inclined plane is root 2gh. Speed at the bottom of a vertical circle in order to complete circular path at least once is v equal to root 5 by 2 gd, where d is the diameter of the circular path. Since both the velocities are equal, we get h equal to 5 by 4 d upon simplification. Three objects, A solid sphere, B a thin circular disc, and C a circular ring, each have same mass and radius. They will spin with the same angular velocity omega about their own axis of symmetry. The amount of work required to bring them to rest would satisfy the relation. Rotational kinetic energy of object A, solid sphere, is half I omega square, that is half 2/5 of mr square into omega square, that comes out to be 1 by 5 mr square omega square. Similarly, rotational kinetic energy of object B, that is circular disc, half I omega square, half of half mr square omega square, which comes out to be 1 by 4 mr square omega square. Rotational kinetic energy of circular ring is half of mr square omega square. Moment of inertia of circular ring is mr square. That comes out to be half mr square omega square. Applying work energy theorem, W net equal to delta K, since the objects have to stop, the final kinetic energy is 0. So the work done equal to change in kinetic energy, that is equal to K. As you can see from the expressions for kinetic energies, Kc is greater than Kb is greater than Ka. So work done on C is greater than work done on B and greater than work done on A. Which one of the following statements is incorrect? Frictional force opposes the relative motion. Limiting value of static friction is directly proportional to normal reaction. Rolling friction is smaller than sliding friction. Coefficient of sliding friction has dimensions of length. Let us analyze the statements one by one. First statement: frictional force opposes relative motion of point of contact between two surfaces. So it is a correct statement. Limiting value of static friction is directly proportional to normal reaction. So it is also a correct statement. Rolling friction is smaller than sliding friction. That is true. This is how we use wheels for vehicles in order to convert sliding friction into rolling friction. Then coming to the fourth statement, coefficient of sliding friction has dimensions of length. That is wrong, because coefficient of friction is a ratio of two similar quantities. So it is a dimensionless quantity. A moving block having mass m collides with another stationary block having mass 4m. The lighter block comes to rest after collision. When the initial velocity of the lighter block is v, then the value of coefficient of restitution E will be. Apply conservation of linear momentum. Initial momentum mv plus 4m into 0 equal to final momentum m into 0 plus 4m into v, from which we get velocity after collision equal to 1/4 of velocity before collision. Applying the formula for coefficient of restitution, E equal to relative velocity of separation by relative velocity of approach. Substituting the given values, we get E equal to 1/4. A tuning fork is used to produce resonance in a glass tube. The length of the air column in this tube can be adjusted by a variable piston. At room temperature of 27 degrees centigrade, two successive resonances are produced at 20 centimeter and 73 centimeter of the air column. If the frequency of the tuning fork is 320 Hz, then the velocity of sound in air at 27 degrees centigrade is. Let us see the given data once. Frequency is 320 Hz. The two resonating lengths are 20 and 73 centimeters. So the velocity of sound from resonating air column experiment V equal to 2F times L2 minus L1. Put the values to get the velocity of sound as 339.2 meter per second. The electrostatic force between the metal plates of an isolated parallel plate capacitor C having a charge Q and area A is proportional to square root of distance between the plates, linearly proportional to the distance between the plates, independent of distance between the plates, and inversely proportional to distance between the plates. The electrostatic force of attraction between two oppositely charged plates of a parallel plate capacitor is given by the formula Q square by 2A epsilon naught, from which we can see the electrostatic force is independent of distance between the two plates. A pendulum is hung from the roof of a sufficiently high building and is moving freely to and fro like a simple harmonic oscillator. The acceleration of the bob of the pendulum is 20 meter per second square at a distance of 5 meter from the mean position. The time period of oscillation is. Acceleration of a simple harmonic oscillator A equal to omega square x. So from there we get omega is 2 radian per second. Time period of oscillation T equal to 2 pi by omega, which comes out to be pi seconds. An electron falls from rest through a vertical distance h in a uniform vertically upward directed electric field E. The direction of electric field is now reversed, keeping its magnitude same. A proton is allowed to fall from rest in it through the same vertical distance h. The time of fall of the electron in comparison to the time of fall of proton is. Let us say mass of electron is small m and mass of proton is capital M. The electric field is E, which is initially in upward direction. Time taken to fall through a height h from rest for the electron is h equal to half at square. So here A is acceleration, which is caused by the electric field. So the acceleration due to electric field is EQ by m. Now the electric field is reversed in direction, keeping the magnitude same. So the time taken to fall a height h from rest for proton is h equal to half at square, which is half of EQ by capital M into t square. Since height is same in both cases, we can equate them to obtain the ratio as t by t whole square equal to small m by capital M. So from there small t equal to capital T times square root of small m by capital M. As we know, proton is almost 2000 times heavier than the electron. We have the time of fall of the electron is smaller than that of proton. An electron of mass m with an initial velocity v bar equal to v naught I cap, where v naught is greater than 0, enters an electric field E bar equal to minus E naught I cap. E naught is a constant which is greater than 0 at t equal to 0. If lambda naught is the de Broglie wavelength initially, then its de Broglie wavelength at a time t is given by initial de Broglie wavelength of the electron lambda naught equal to h by mv naught. The electron will accelerate as the field is along negative x-axis and initial velocity is along positive x-axis. The speed of the electron after some time given by the formula v equal to u plus at. So that is v naught plus EQ by m, that is acceleration. In this case it is E times E naught by m into t. The de Broglie wavelength after some time lambda equal to h by mv. Putting the value of velocity there, we get lambda equal to h by m times v naught plus E naught by m into T. Simplify this formula to obtain the final answer lambda naught by 1 plus E naught by mv naught into T. For a radioactive material, half-life is 10 minutes. If initially there are 600 number of nuclei, then the time taken in minutes for the disintegration of 450 nuclei is. Half-life of the radioactive sample is 10 minutes. Initial number of nuclei is 600. Given that 450 nuclei have to disintegrate, so the number of nuclei remaining is 150. Applying radioactive disintegration law, n by n naught equal to 1 by 2 power T by T. Upon substituting the numerical values, we have T equal to 20 minutes. When the light of frequency 2 nu naught, where nu naught is threshold frequency, is incident on a metal plate, the maximum velocity of electrons emitted is V1. When the frequency of the incident radiation is increased to 5 nu naught, the maximum velocity of the electrons emitted from the same plate is V2. Then the ratio of V1 to V2 is. Apply Einstein's photoelectric equation E equal to phi plus k max, where E is energy of incident radiation, phi is work function of the metal surface, k max is the maximum kinetic energy of the electrons released. The equation can be rewritten as h nu equal to h nu naught plus half mv square in terms of frequency. So for the first frequency 2 nu naught, we can write 2 times h nu naught equal to h nu naught plus a half m v1 square. For the second frequency, we can write 5 times h nu naught equal to h nu naught plus a half m v2 square. Upon simplifying the values, we have the ratio of velocities v1 by v2 equal to 1 by 2. The ratio of kinetic energy to total energy of an electron in a Bohr's orbit of the hydrogen atom is total energy of the electron in Bohr's orbit minus k times e square by 2r, where r is the radius of the orbit. Kinetic energy of the electron is k times e square by 2r. So taking the ratio, we have 1:-1. An electromagnetic wave is propagating in a medium with a velocity v bar equal to v I cap. The instantaneous oscillating electric field of this electromagnetic wave is along a positive y-axis. Then the direction of oscillating magnetic field of the electromagnetic wave will be along. Velocity of the electromagnetic wave v bar equal to v times I cap. So it is traveling along positive x-axis. Direction of the electric field is along a positive y-axis. Propagation of electromagnetic wave is given by v bar equal to E bar cross B bar. So the direction of propagation of electromagnetic wave is along the cross product of electric field vector and magnetic field vector. To obtain an answer of x-axis, we should have the magnetic field should be acting along a positive z-axis. The refractive index of a material of a prism is √2 and the angle of prism is 30 degrees. One of the two refracting surfaces of the prism is made a mirror inward by silver coating. A beam of monochromatic light entering the prism from the other face will retrace its path if its angle of incidence on the prism is. See the diagram carefully, take your time. From the triangle AMN, we can write 30 plus 90 plus theta equal to 180. Sum of the angles in a triangle is 180, from which we get theta equal to 60 degrees. Angle of refraction R equal to 90 minus theta, so it is 30 degrees. Given the refractive index of the prism is √2, applying Snell's law at n1 sin theta 1 equal to n2 sin theta 2. By substituting the values, we get angle of incidence equal to 45 degrees. The magnetic potential energy stored in a certain inductor is 25 millijoule when the current in the inductor is 60 milliampere. The inductor is of inductance. The magnetic potential energy stored in an inductor is given by the formula half I square L, where I is current flowing through the inductor and L is inductance value. By substituting the given numerical values, we have inductance equal to 13.89 Henry. An object is placed at a distance of 40 cm from a concave mirror of focal length 15 cm. If the object is displaced through a distance of 20 cm towards the mirror, the displacement of the image will be. Initially, the object is placed at 40 cm from the mirror. For the initial position of the image, we apply mirror formula 1 by v plus 1 by u equal to 1 by f. For a concave mirror, all the physical quantities are negative. So we get v initial equal to 24 centimeter. For final position of the image, we apply the mirror formula again. This time the object distance is 20 centimeter. So we obtain the final position of the image is 60 centimeter. So the displacement of the image is 60 minus 24, that is 36 centimeter. As the object is moving towards the mirror, the image will be moving away from the mirror and it will get magnified. A toy car with a charge q moves on a frictionless horizontal plane surface under the influence of a uniform electric field E. Due to the force QE, its velocity increases from 0 to 6 meter per second in 1 second duration. At that instant, the direction of electric field is reversed. The car continues to move for 2 more seconds under the influence of this field. The average velocity and average speed of the toy car between 0 to 3 seconds are respectively. Let us find the acceleration of the toy car from the formula v equal to u plus at. Final velocity is 6 meter per second. So from there we get acceleration equal to 6 meter per second square. Distance traveled during this time s equal to half at square, which comes out to be 3 meter. As the direction of the field is reversed, the acceleration is also reversed. From this point the toy gets decelerated, so its velocity keeps on decreasing and ultimately becomes 0. So time taken for the velocity to become 0 is v equal to u plus at again. It is 0 equal to 6 minus 60, which comes out to be 1 second. Distance traveled during this time, v square minus u square equal to 2as, which comes out to be 3 meter. For the next 1 second, the particle moves in opposite direction. So the distance traveled during this time is again s equal to half at square. So it is 3 meter. So the total distance traveled by the particle is 9 meter. That is the first 3 meter during acceleration, next 3 meter during deceleration, and the last 3 meter after reversal of direction. So the total displacement of the particle is 3 meters. So the average velocity displacement by time, which comes out to be 1 meter per second. Average speed is distance by time, that is 3 meter per second. A toy car with a charge q moves on a frictionless horizontal plane surface under the influence of a uniform electric field E. Due to the force QE, its velocity increases from 0 to 6 meter per second in 1 second duration. At that instant, the direction of electric field is reversed. The car continues to move for 2 more seconds under the influence of this field. The average velocity and average speed of the toy car between 0 to 3 seconds are respectively. Let us find the acceleration of the toy car from the formula v equal to u plus at. Final velocity is 6 meter per second. So from there we get acceleration equal to 6 meter per second square. Distance traveled during this time s equal to half at square, which comes out to be 3 meter. As the direction of the field is reversed, the acceleration is also reversed. From this point the toy gets decelerated, so its velocity keeps on decreasing and ultimately becomes 0. So time taken for the velocity to become 0 is v equal to u plus at again. It is 0 equal to 6 minus 60, which comes out to be 1 second. Distance traveled during this time, v square minus u square equal to 2as, which comes out to be 3 meter. For the next 1 second, the particle moves in opposite direction. So the distance traveled during this time is again s equal to half at square. So it is 3 meter. So the total distance traveled by the particle is 9 meter. That is the first 3 meter during acceleration, next 3 meter during deceleration, and the last 3 meter after reversal of direction. So the total displacement of the particle is 3 meters. So the average velocity displacement by time, which comes out to be 1 meter per second. Average speed is distance by time, that is 3 meter per second. A block of mass m is placed on a smooth inclined wedge ABC of inclination theta as shown in figure. The wedge is given an acceleration a towards the right. The relation between a and theta for the block to remain stationary on the wedge is: as the wedge is accelerated, it becomes a non-inertial frame of reference. So a pseudo force will act on the block in opposite direction. See the free body diagram of the block and the wedge, and take some time to go through all the forces represented on the block. For the block to remain stationary, we can write mg sin theta, the force acting down the inclined plane, should be equal to ma cos theta, the force acting up the inclined plane, from which we get a equal to g tan theta. A student measured the diameter of a small steel ball using a screw gauge of least count 0.001 centimeter. The main scale reading is 5 mm and 0 of the circular scale is 25 divisions above the reference level. If the screw gauge has a zero error of minus 0.004 centimeter, the correct diameter of the steel ball is. Go through the given data once. Diameter of the steel ball, that is screw gauge reading, is PSR plus HSR into LC plus 0 correction. Upon substituting the values, we have diameter equal to 0.529 centimeter. The moment of force F bar equal to 4I cap plus 5J cap minus 6K cap at 2, 0, minus 3 about the point 2, minus 2, minus 2 is given by position vector of the force 2I minus 3K, radius vector 2J minus K. So the applied force is 4I plus 5J minus 6K. Moment of force is R bar cross F bar. We can see the answer comes out to be minus 7I minus 4J minus 8K after cross product. The power radiated by a black body is P and it radiates maximum energy at wavelength lambda naught. If the temperature of the black body is now changed so that it radiates maximum energy at wavelength 3 by 4 lambda naught, the power radiated by it becomes Np. The value of N is. Apply Wien's displacement law, lambda m into T equal to constant. So from there we get T dash as 4T by 3. Now apply Stephen Boltzmann's law, P equal to sigma A T power 4, where sigma is Stephen Boltzmann's constant. A is a surface area and T is absolute temperature. Taking the ratio P1 by P2 equal to T1 by T2 whole power 4. By substituting the values, we get N equal to 256 by 81. Two wires are made up of same material and have same volume. The first wire has a cross-sectional area A and the second wire has a cross-sectional area 3A. If the length of the first wire is increased by delta L on applying a force capital F, how much force is needed to stretch the second wire by the same amount? Given both the wires are made up of same materials, so their Young's moduli will be same. Volume of both the wires is same, so V1 equal to V2. Volume can be written as area of cross section into length, from which we get L1 equal to 3L2. For the first wire, Y equal to FL by A delta L. For the second wire, Y equal to F into L by 3 by 3A into delta L, which comes out to be FL by 9A into delta L. From the two expressions, we get small f, that is the force required for the second wire, equal to 9 times capital F, that is force applied on first wire. A sample of 0.1 gram of water at 100 degrees centigrade and a normal pressure 1.013 into 10 power 5 Newton per meter square requires 54 calorie of heat energy to convert into steam at 100 degrees centigrade. If the volume of steam produced is 167.1 cc, the change in internal energy of the sample is. Work done during the process dW equal to PdV, that is 1.013 into 10 power 5 into change in volume 167.1 minus 0.1 into 10 power minus 6 converted into meter cube. So that comes out to be 16.9171 joule. Heat input during the process dq equal to 54 calorie, converting into joule, 1 calorie equal to 4.18 joule. So 54 into 4.18, which comes out to be 225.72 joule. Now the change in internal energy of the process, applying first law of thermodynamics, du equal to dq minus dw, that is 225.72 minus 16.9, which is 208.7 joule. A small sphere of radius r falls from rest in a viscous liquid. As a result, heat is produced due to viscous force. The rate of production of heat when the sphere attains its terminal velocity is. Terminal velocity of the sphere V equal to 2 by 9 r square g rho 1 minus rho 2 by eta. From there we can write terminal velocity is directly proportional to square of the radius. Then viscous force acting on the sphere is 6 pi eta Vr, where eta is a coefficient of viscosity. So from here we can see viscous force is directly proportional to radius of the sphere. Substituting the value of velocity in this formula, we get viscous force is directly proportional to cube of radius of the sphere. Rate of production of heat is nothing but power equal to force into velocity. So power is proportional to r power 5.